Good afternoon, everyone. This is Dr. Frelin B. Mobo. I'm one of the faculty members and Assistant Director for Research at the Philippine Merchant Marine Academy. I'm about to present about the neural network. So first, we need to define what is a neural network is all about. Okay, so when we say about neural networks, it is a group of connected input-output of units where each connection has a way associated with its computer program. So meaning these are data processes that can process an algorithm which helps build predictive models from large databases going from other areas or databases. So this model builds upon the human nervous system, just like an example, it helps you to conduct an image understanding of human learning, computer, speech, etc. So this is what we call the neural networks. Okay, so under the neural networks, as we go along with the discussion, we have also the backpropagation under neural networks. So a backpropagation is the essence of neural network part. It is a method of fine-tuning the weights of neural network based on the error rate obtained in the previous iteration. For example, if the first process going to the next process, there is the part where we're in to avoid problems. So this is the proper tuning of the weights which allows you to reduce error rates and makes the model reliable by increasing its generalization. So it's very important to do this backpropagation because in the neural network, it is a short form of backward propagation of errors wherein you are doing fine-tuning and removing all the possible problems. It is also standard method of training artificial neural networks that can help calculate the gradients of loss function with the rest of all weights in the network. So backpropagation plays a vital role. And this is how the process goes on. So I have here a diagram which shows how backpropagation algorithm really works. No? For example, the backpropagation algorithm in neural networks computes the gradient of loss function for a single weight by the chain rule. So it is efficiently computes one layer at a time. Unlike a native direction computation, it also computes the gradient, but it does not define how the gradient is used. It generalizes the computation in the delta row. So we have to consider the backpropagation network as an example of the processing algorithm. And it's very important to do that function because as you check the background that we have, how it works is that on the first one, we're supposed to we have to input the variable of x on number 1 that arrives through the pre-connected path. No? So on the second process, input is modeled using real weights on variable w. So the weights are usually random selected. So on the next part, it can calculate the output of every neuron from the input layer to the hidden layers to the output layer. And it can calculate the error in the outputs by using the formula error equal to actual output minus desired output, which means on the last part, it can travel back from the output layer to the hidden layer to adjust the weight such as that the error is decreased. Then you have to keep repeating the process until the desired output is achieved. Just like an algorithm, not something like a blueprint wherein you have to go to the first phase, then you have to go to the last phase, then going back until the process has been achieved. So that's the process of doing a back propagation. So the question there is, why do we need a back propagation? Of course, most prominent advantages of back propagations are the following. Of course, in terms of processes and algorithm in computer science using neural networks, it is fast, simply, and easy to program. It has no parameters to tune up apart from the numbers of being input or variables. It is flexible method as it does not require prior knowledge about the network. And it is understand method that generally works well because of its processes going to several stages, just like a blueprint or an algorithm. It does not need any special mention of the features to be function to be learned. That's why that's the way why do we need the back propagation. And next is what is a feed forward network? So it's being defined just like back propagation. Uh, forward network, it's a neural network in an artificial neural network where the nodes never form a cycle. So which means that this kind of neural network has an input layer, a hidden layers, and an output layer, and it is the first and simplest type of artificial network that can process. Okay? So it is very simple, but yet it can do those things. So we have two types of backward propagation networks. So the first one, we have the static type backward back propagation, wherein it is a kind of back propagation network which produces a mapping of static input for a static output. So means it is useful to solve static classification issues like optical character recognition. So for example, if you're going to use a scanner method, doing that way, once you scan that object, definitely it'll just capture everything. So that's what we are talking about on a static back propagation. On the recurrent back propagation, it is a propagation in data mining which is being fed forward until a fixed value is achieved. After that, the error is computed and propagated backward. So the main difference between both of these methods is that the mapping is rapid in static back propagation while it is as non-static in recurrent propagation, which means that they have differences. Okay, so just like using a scanner, when you use that, it has a pattern wherein it can do the function and can read all the properties. Okay, so for the history of the back propagation, it is being said that during the 1961, that is the basic concept of continuous which were developed and derived in the context of the control theory of the scholar under J. Kelly, Henry Arthur, and E. Bryson. So in 1969, Bryson and who gave a multi-stage dynamic system optimization in this method, wherein the continuous backpropagation emerged. Okay? But in 1974, wherein Verbo stated that the possibility of applying this principle in artificial intelligence or neural network really works. But in 1982, another scholar, Hofield, philosopher, broke this idea of a neural network. But in 1986, by the effort of David E. Rumelhart, with the following scholars, Geoffrey E. Heaton, Ronald J. Williams, they have gained recognition from the back propagation method. But in 1993, one was the first person to win an international pattern recognition contest with the help of back propagation method because of that process. So it really plays a lot, okay? Because back propagation key points under that simplifies the network structure by elements, weighted links that have the least effect on the trained network. So you need to have a study group of input, just like what I've shown to you a while ago, and activation values to develop the relationship between variables, input variables, and other hidden unit layers. So it helps to assess the impact that give an input variable as a network output. The knowledge gained from the analysis should be represented in this rule. So backpropagation is especially useful for in-depth neural networks working on error-prone projects such as image or speech recognition. So these things are really important, especially when you are doing layout, graphics designing, or voice recognition. These things really works in backpropagation. So backpropagation takes an advantage of chain and power rules that allows the algorithm to function with any number of outputs, just like an encryption method. So what is best practice propagation? It's being said that the backpropagation in neural network can be explained with the help of a shoelace analogy. Simply as that. Okay? So too little tension, but too much tension. Okay? Pulling one lace more than other, just like that. Okay? Now, but the disadvantage of using backpropagation is that the actual performance of backpropagation in a specific problem is dependent on the input data, which is really true. For example, once a scanner and printer loads it data, so we will never know now what will be the process, no? But backpropagation algorithm in data mining can be quite sensitive to a noisy data, which is you need to use matrix-based appropriation for backpropagation instead of mini-batch. So this one, the backpropagation, as we go along with the discussion, this is an algorithm which really helps a lot in terms of image processing and recognition, especially in photos or pattern recognition, or especially in this time of pandemic. It really helps a lot. So that would be all. Thank you and good day.